So the first of the B series review videos is about logarithmic and exponential forms of an equation. And again, this is something you should have seen before. We should have seen this in the intermediate algebra class, but I did want to review it here. And what it's really about is us recognizing that there is a logarithmic form for equations, and those equations also have an exponential form, right? So for instance, the logarithmic form would look something like the log base 9 of 27 equals 3/2. And the information encoded in that, what that means is exactly the same as if I were to say 9 to the 3/2 power equals 27. And so the idea is simply that the base of the logarithm becomes the base of the exponent. The thing being evaluated in log becomes the what you're equal to in the exponential form, and what the logarithmic form is equal to becomes the power of the exponential form. So for instance, if I had the log base 1/2 of 8 equals x, we should be able to rewrite this in exponential form. And so if you're watching at home, I'd recommend that you pause and try that one. According to what I said before, this should be 1/2 to the x power equals 8. And as a side note, I might mention, now that we've done that, it actually may become easier for us to solve for what x is. Like, I know we could have done that back here by thinking about it, but rewriting an exponential form is often sort of the written version of thinking about it and figuring out what's going on. So if we do sort of step sideways here, what would x need to be here? And I hope that some of the thoughts that you guys think are, well, if x was 3, then the 1/2 would become 1/8. So we sort of, we mentally consider that, okay, well, I know 1/2 to the 3rd power is 1/8. But if I want to get not a 1/8, but a real 8, how could I get that real 8? Well, if we use a negative 3rd power, it'll take this thing and raise it to the -1 power, which will give us that positive 8. That sort of shows us that the x back here in this problem, in either one of these things, we would have found that x is -3. Because these equations are equivalent to one another, they both end up with the same solution, x equals -3. I might note that this can only be done if something is written strictly in logarithmic form or strictly in exponential form. So for instance, suppose that, and I suppose the other thing I could mention is that this can also go backward. Suppose that somebody's got an expression like 2 times 5 to the x power equals 30. Right? Can this be written back in logarithmic form? And it can. My complaint is that this, strictly speaking, is not in exponential form. It's not a base to a power equals a number. This has the base, the power, and the number, but it also has a 2. And so the first step that you actually have to take is to work with this side a little bit more. I would want to divide both sides by 2 and get 5 to the x equals 15. Now that this thing is in exponential form, it can be rewritten. Right? So just like we've done on the previous ones, this would be the log. We take the base of the exponent 5 and make that the base of this. Then we take the thing that this power is equal to, 15, and that's what I'm taking the log of. And this is equal to the power that's being used here, x. As you can tell from the numbers, this is not something that can be evaluated by hand. This is something you'd have to use the calculator for. And as a way of reminding you, the change of base formula for this would give us something like the log of 15 over the log of 5. I know right now these questions don't have much direction on them. I'm not really asking questions. I'm sort of just showing you what can be done with them. So this is that concept of moving back and forth between forms. I did have one last problem for us, and this is a slightly more complicated problem, another application of this stuff. I could give you something like solve for x solve for x in this equation. The log base 14 of x plus 3 plus the log base 14 of x minus 2 equals 1. Which really probably feels a little bit on the crazy side. You're like, wow, where do I even start? And the thing I tell my intermediate algebra students all the time when we're working on this chapter, and the thing I would tell you as well, is that so many times the secret on solving weird logarithm problems and on solving weird exponential problems is just changing their forms. Like, this problem is close to being logarithmic form, but it's not. And I might mention, so what again makes something logarithmic form? What makes something logarithmic form is when we have the log of some base of something equals some number. This is what logarithmic form really is. So it's a single log equals a single number. So here you'll notice I don't have that. I have two logs, right? Fortunately, they're being added together, so from the first review video, you know that we can multiply these things together. I can get the log base 14 of, and then inside will be this times this. I'm going to go ahead and FOIL those together and get x squared plus x minus 6 equals 1. And now I'll admit it's a little bit complicated, but this is logarithmic form. This is a log base something of one large expression equals 1. There's no reason I can't change the form of this. That I can't say, okay, this means 14 to the first power equals x squared plus x minus 6. And at this point, like, we have reduced a crazy addition logarithm problem into basically a factoring problem. If I just move the 14 over, x squared plus x minus, it's actually not minus 6 anymore, now it's minus 20. Let's make that 2 a little bit prettier. Minus 20. And now this can be factored. This is x plus 5 times x minus 4. And so the two solutions are x equals negative 5 and x equals positive 4. Although only one of these solutions actually works. It's this one. And some of you may be thinking, oh yeah, because the negative one doesn't work. Kind of. What you really have to think about is, if you were to take these and plug them back in to either one of the places, what happens with them? And the reality is, when you plug in the x minus 5 up here, when you plug in negative 5 here, you're going to get negative 2, and we learned in the previous video, I think I covered it, that you can't take the log of a negative number. So this one is out. And again, I want to emphasize, it's not because this is negative. It's because when you plug that back in, this becomes negative. Right? If you take a look at the 4 instead, when you take 4 and plug it in up here, 4 minus 2 is 2. If you take the 4 and plug it in over here, 4 plus 3 is 7. Both of those are positive, which means this answer is good and acceptable. I think that's all I had to say for logarithms in this video, and that's actually the end of the review of logarithms. So as far as I'm concerned at this point, I hope that you've got all the basics you need for logarithms for the rest of the chapter. The other videos in the B series are about inverse functions. So if you need to review those, I'll see you in those videos.